We're on. Okay, here we go, dudes. We're live. All right. We want to apply, the whole point of mathematics is to apply it to the real world so you can solve real world problems. Kind of why we do these things. So we want to figure out how can I apply my knowledge of writing equations of lines to write equations that affect real world situations. Okay, still, you have only two choices you can use here. What are your two choices?
Slope.
When you're writing the equation of a line, you have two ways you can do it. Slope intercept and point slope. Okay, those are your two choices. Your trick here is going to be to read the problem and go, which one do I have to use to get there? And so we'll keep that in front of us. So we're going to look at number one here, and I need to up my data. This is too cheap. Maybe this is I don't even think in Seneca, Kansas, it would be this cheap a taxi, if we had a taxi. We once did. So suppose the taxi cab fare, the fare is the amount you pay to ride in the taxi cab. Imagine it's $4. If you get in the cab, it's $4. Plus $1.20 per mile you travel. That's cheap, right? If you were in a big city today, it would be more than that. Okay, I want you to write me a function, an equation for the total fare, how much you're going to pay if you travel X miles. So when we get done, it said write an equation for the fare. Since it said write an equation for, if it says those words, that's telling you, in this case they went for the fare, that's telling us we want F equals. That's going to be your y coordinate. Whatever they say write an equation for, that's your y coordinate. And then they're always going to say in terms of a different variable, in terms of da-da-da-da-da-da, that's always your x coordinate. If you read the words, they'll tell you which one's y, which one's x. Okay, my question to you is this going to be a situation where we're going to use slope intercept or point slope? Point slope, you usually had to know what to do it. Just 1 point? Most of the time of your homework assignment yesterday, you had two sets of coordinates, and that's typically what will happen here in real world situation. You have several sets of coordinates, several facts about this real world situation. Just like with the Fahrenheit and Celsius, we knew we had a coordinate for when it was boiling and a coordinate for when it was freezing. So if you've got a couple coordinates information, point slope's probably your way to go. Okay, slope intercept though. When you guys graph with slope intercept, what do you graph first? You graph the y-intercept, which is kind of like a starting value. You have some start point, and then you count the slope off of it. So if you've got a real-world situation where you have some starting amount, and then it's going to rise, increase, or decrease from there, that kind of screams, hey, dude, I'm slope intercept. So what's this one with the taxi cab fare? Why is it slope intercept? It doesn't give you two sets of coordinates. That's one thing. And, okay, it tells you it's $4 if you get in the cab plus $1.20 per mile. Okay, so what's your starting dollar value? You're starting with $4 and it's going up $1.20 per mile. They told us to write an equation for the fare. Fare is how much we're going to spend. Actually, let me do it in y's here so I don't confuse you. Okay, he said 4x plus $1.20. Buying that?
Y equals $1.20x.
I got the other way. $1.20x plus 4. Which one? Yeah, because logically, didn't want that. Move down. Give me that. Okay, so yeah, we start at $4 and it goes up $1.20 per mile. So it makes sense that that would be the second one. So we don't want this one. Now, what they want you to do, though, is they want you to use the letters they indicated. They said for the total fare, F. So which one of those should be F? Y should be F. So typically they'll write it as F of X. They said in terms of miles, and miles was supposed to be X. So we're fine with that. I could have used M as well. But ta-da, you just found the equation. Boy, that was a tough amount of work, wasn't it? Whew, worked hard. Then it's going to ask you, so what's the cab fare going to be after a 14-mile trip? Yeah, you're going to plug 14 in for x, and so technically you're trying to find f of 14. So you're going to be $1.20 times 14 plus 4, which I believe, if I remember right, comes out $20.80. And so that's actually probably too cheap by today's standards. And okay, where would you be going that you would take a 14-mile trip? Well, okay, here, if you're in Kansas City, it's probably 14 miles. It's probably even more than that from the airport into the main city, because the airport's way out on the edge of Kansas City. So, you know, if you take a taxi from the airport, it's going to be fairly pricey. Now, if you got 2 or 3 people in the taxi, it's not a bad deal. But now, the thing this one does not talk about, if you've been in a taxi in a big city in recent years, if it's a city that has traffic issues and you could be sitting in traffic for some time, it stops, if it sits for like more than 1 minute or 2 minutes of time, if you're sitting parked in traffic or something, it switches over and it starts charging you by the minute instead of by the mile. So even if you're stuck in traffic, you still get to pay for all that time you're stuck in traffic, because that cabbie is still using his gas and his time, so it will roll over to being a per minute deal if you're not in motion. Oh. All right, so that was doing a nice one when you can spot, oh, I have a starting value, I have a slope. Big hint, it was something per mile. If they tell you it's something per foot, something per hour, that's always we talked about slopes or rates of change. So if they're telling you it's moving at some rate, that's going to be slope. It's a guarantee it's going to be slope. Okay, trickier would be, we're actually going to skip down, we're going to do number 3. We're going to go do some plumbing here. Our plumber charges a service fee plus an hourly rate, and this is factual too. They show up at your house, you got to pay X number of dollars because they showed up at your house, plus so much more per hour while they're there to work. If they do the service call, you're going to pay for the call regardless of how long they're there. So in this particular case, this plumber charged $53.75 for a job that took 2.5 hours. And $45.70 for a job that took 1 hour and 48 minutes. And they want you to come up with an equation explaining the cost in terms of the number of hours he worked. So possibly, that's not unheard of by any stretch of the imagination. My question is this a point slope situation or a slope intercept situation? Why? Am I telling you a start? He said there's not. Am I telling you a starting amount and how much he's charging per hour? Nope. So am I giving you information that can be turned into coordinates? I gave you 2 sets of information. That screams, hey dudes, I'm a coordinate. So yeah. So looking at number 3 on that sheet here, okay, here's the big question. You got to figure out which is X and which is Y. Is the hours X and the cost Y, or is the cost X and the hours are Y? How do I know which way it should be? Read 3A. It says, write an equation for cost in terms of the hours for cost. Okay, I just told you back on the last screen, how do you know which one's Y? Whatever it says for, write an equation for. When they say write an equation for cost, that's Y. Always. Whatever they say write the equation for, that's Y. Whatever they say in terms of always means that's your X. So cost is Y, hours are X. So when I look at his data, should I put the 53.75 first or the 2.5 hours first? We just said X was going to be hours, so it's got to be 2.5 hours, 53.75. Okay, now what's evil about the second set of information? They didn't. I told you 1 hour and 48 minutes. You can't calculate with 1 hour and 48 minutes. That was 2.5 hours. I need this as a decimal. So how do I turn 1 hour and 48 minutes to a decimal?
You take 60 plus 60 plus 48.
Well, that would be if I wanted to turn it all into minutes, but since this one's in 2.5 hours, I can't have them be different. They've got to be in the same form. Dudes, how do you turn 48 minutes into a part of an hour?
48 divided by 60.
Yes.
Thanks, Shelley.
48 divided by 60 is 0.8. So in other words,
1.8.
it's 1.8 hours. Thank you. Yeah. You have to have your units the same. You couldn't have different sets of units before you did this. Okay, so now you got two coordinates. How do we write equations of lines when we have two coordinates? What do we do?
Coordinate slope.
Well, I'm going to do point slope, but first I have to find slope. Okay, which in this one it's totally logical which order to subtract these in. Yeah, the 5375 minus 4570 over the 2.5 minus 1.8. So that's $8.05 there. I did it twice yesterday, dude. And divided by 0.7. I don't remember this one. 7. We'll go. 11.5. Okay, thank you. All right, so what does that mean? If the slope is 11.5, in this situation, that's 11.5 what? What's that have to do with how much he's charging you? 11, yeah, he's charging you $11.50 an hour to work at your house. That's what his hourly rate is, $11.50. That's not that much, that's too cheap. Like I said, I need to update this data and make it all more expensive. So if you hope you get a plumber this cheap, you better be calling this guy if he's any good. Okay, so I have a slope. If there's a slope, how do I turn it into an equation? Because am I doing slope intercept or point slope? I got points, so I'm doing point slope. So I'm filling it into this equation. Okay, this one's up to you now. Which point you want to use? I don't know that I think either one of them is particularly nice numbers, so which point you want to use? The first one, the 2.5 and the 5375. Okay, so in that case, if that's the point I'm using, I'm going y minus the y coordinate in that point, which is 5375, and the slope is 11.5. I need to write with my finger here. X minus our x coordinate was 2.5. Okay, I'm going to need somebody with a calculator in hand to help me here.
I got you.
Okay, I can handle 11.5 times x, but 11.5 times 2.5. 28.75, thank you. And then last but not least, what do I need to do to finish it? Yeah, there we go. Add the 5375, so those cancel. Okay, notice that's negative 28, that's positive 53, so you actually have to subtract those. And yeah, they subtract very nicely, don't they? So therefore, what's he charging to show up at your house for the service call? He's charging $25 and you're paying $11.50 an hour. Now, it does want you to switch it over. They said write it for cost, so they would want you to change it over then to cost is equal to 11.5x plus 25. And that's a pretty cheap plumber by today's standards. Okay. Part B of, actually it's part C of that. I didn't want to ask you that. I wanted to ask you the opposite. Okay, I'm making up my own question. I want to know if he ended up charging you, I'm doing some math here real fast. If you ended up paying if your bill was $117, how long was he there? I want to know, how many hours did he work at your house?
Put that in for the X.
Is that the X?
The X. Or Y. Put it in for the Y.
So your bill is $117. So is that the cost, or X is the number of hours?
It's cost.
It's cost. So yeah, you would set the cost equal to 117, and then you could solve for the hours, could you not? Which would not be exceedingly difficult. I think we can solve for X. If I subtract 25, I'm going to be down to 92. And hopefully if I did my math right, 11.5 goes into 92. Or 8 times. So he was there for 8 hours. Dude, you have a plumber at your house for 8 hours. If you got by for $117, you better celebrate. That would be really good. Madeline said yesterday her dad charges $55 for the service call, and she couldn't remember how he works the hourly thing, but
My dad just charges $100 just for the call.
so, okay. Not that hard. It's either point slope intercept, you can find the starting value and how much is increasing, decreasing. Excuse me, you are a disruption to my class. Or you can do coordinates. That's what this paper is. So some of these are going to be look at it right in slope intercept form. It's going to be super simple to write the equation. Some of them are going to make you do point slope and actually have to work it out. No one has died from this paper. But this is the whole point of the real world, dudes. Math is all about modeling the real world. That's why we do it. We do not do it just to torture students. Pretty sure.
I didn't use math yesterday.
Baloney.
I don't think I used it during the summer.
Did you figure out yardage?
Nope.
You ran, traveled?
I ran a mile. I never used math this summer.
You never paid for anything with money.
That's like addition and subtraction.
That's math.
It's not this math.
That's not this math, true. All right. Grab a calculator. If you got a purple piece of paper, it'll help. Oh, we're not going to get far enough. I can tell you that right now already. We are going to do some calculating here. All right. Remember we made the scatter plots. Now our goal is to find a line to fit the scatter plot. When you have a set of data in a scatter plot and you're trying to fit a line, or later this year we'll fit curves as well, that's called regression. That's the name of the process. Okay, it's actually an extremely complicated statistics process. It is. I've done it by hand. It is unfun to do by hand. It is a ton of calculation that actually happens, because what it does is it actually figures out where is the best line.
Which ones are homework?
Both.
Do both, all of them?
Possibly. It depends on how far I get. I'll tell you at the end here. Okay, so I first need you all to make a scatter plot. This is the data. And yes, I know I redid this sheet a couple years ago, and yes, I know that I don't have Peyton Manning and Brett Favre are now retired. I'm sorry. I'm not redoing my data every year. Yeah, is he? Oh, they told me yesterday. What were they complaining about then? But Peyton Manning is now got the most yardage, doesn't he? I think didn't he top that last year? So, okay. Well, anyhow, this is how many touchdowns in the career, how many yards they threw for. Okay, would you assume there's a relationship between the number of touchdowns you have and the number of yards you've thrown for? Yep. You would assume that if you threw for more yards, you probably have more touchdowns. We would think that. Okay, so let's check the scatter plot and see. How did I make the scatter plot? I add a page. How do I add a page? Control doc. Add graph. Remember, this is a data and statistics page, so it's number 5 I add. And it puts all those random dots on there.
We've got to set the X and Y values.
And then you have to tell it which is on the X and Y axis. Okay, you need to read my piece of paper. It'll be underlined trying to draw your attention. It says the yardage should be graphed on which axis? Yardage should be on X, touchdowns should be on Y. So if you use your touchpad and come down here and click on the X axis, that's supposed to be yards. And then if you use your touchpad and come over, that's supposed to be touchdowns. Okay. A, what kind of correlation does it have? That's a positive correlation. B, does it look like a line would model it?
Yeah.
Looks like you could put a line through there. Now, here's the question. When you put a line through there, how do you judge where the best line should be? Okay, I got a vote for hit the most dots you can.
You go through the center.
Okay, I got a vote for we go through try to get down the middle of the dots. I got a nodded over here agreeing with that. Okay, I had somebody yesterday who said you want to make sure you hit the highest and lowest points. So they'd want to hit this one and that one. Okay, well, the calculator's been programmed to do this for you. So I'm going to let it put in there, and we'll find out which way was the right answer. Okay, this is on the purple sheet still. If you want to put a regression line on this graph, everything is under menu here. If in doubt, press menu. Menu. Okay, and if you're reading the instruction sheet, which he is, yes, you're going to analyze your graph, number 4, and you're trying to do what of the blacked in ones? Regression, number 6. This is all on the purple sheet. And then you will see all the different kinds of regression it can do. It can do lots of different kinds. Okay, notice we actually want linear. And I don't know, I have the answer to this question. I do not know why there's a plus bx on the bottom. Why there's 2 different choices. I don't know who uses the other one, but we're doing lines with mx plus b. We're using the first choice. I don't know why there's a second. And so it puts the line on there for you.
Whoa.
Okay, so did it hit lots of points or did it go down the middle?
Middle.
Yeah, the goal is to get an even amount of points on each side of the line. You want balance of points on each side of the line. Actually, your line could miss every single point. If the line misses all the points but it's down the middle, that's all we care about. How many points you hit is unimportant. It's down the middle that we want. Okay. Mitchell, been through that. Pay attention. Okay, so notice this was not exactly your nice equation with pretty little, you're not going to get 4x plus 3 as an answer here. Look at those hideous decimals you got as answers for this equation. That's real world data. You're not going to get pretty little nice numbers. How do I move the equation? For you all, you have to take your touchpad and get your hand, when you get on top of it, you'll get your hand. And then you have to hit Control, click in the middle, and the hand will close on it. And then you can drag it wherever you like once you've grabbed hold of it. Hit escape when you want to let loose. Okay, so now here's the bad news. This is one thing that frustrated me about this calculator. I've done that. I've got the regression equation there. I want to use that equation to predict other things, to predict different times. If you've done it on its data and statistics page, you can do nothing but look at it. We can't calculate a thing off of this. Just drives me crazy. It's just to see what it looks like. Don't like that, but we're stuck with it. So if I actually want to be able to use this equation and say, okay, what if somebody throws for 10,000 yards, approximately how many touchdowns would they have? I can't do that way right here. I can't have the calculator find that for me. So we have to go back to the first page. Okay, 2 ways to go back a page. You can come up here and click on 1.1. That's the slow way. you can hit Control left arrow and it'll go back a page. Control right arrow goes forward a page. You'll see in blue out here to the sides, it's forward and backward a page. Okay, we have to run the regression again, unfortunately, on the spreadsheet page to actually be able to calculate with it. Okay, if I leave my cursor sitting right here, when I run this, I'm about to tell it to run a formula for us, it's going to copy over my data. You need to make sure you're out on a blank column before you run this so you don't cover up your data. So make sure you're always out on a blank one. And then you're going to go, and if you're following the purple sheet, we are on the regression lines and curves part. We are on the letter C. Put your cursor in a blank column. Then it says select menu. Okay, but notice the menu changed now because now we're on a spreadsheet page, so now it's giving us spreadsheet choices. Which one do you think might have this in it? Statistics, because it's a stat calculation. So you're going to go statistics, and then you're going to go to a stat calculation. And there's a few.
Linear regression.
Linear regression number 3 now.
Oh, you need to calm down. Yeah, sure.
He is fine. Leave him be.
He's getting too excited.
Of course, it's math. You would get excited. Okay, it's going to ask you, it's going to pop up this dialog box, and it's going to ask you, okay, what did you want your x coordinates to be? Which column in your spreadsheet? For you all, you can either use your touchpad and come over and click on this arrow, or if you hit the right, I think if you hit the right arrow a couple times, it'll drop down, and you can choose. We put which one on the x-axis. Yards was on the x. So you're going to have to put yards on the x. Anytime you want to move to the next box, hit tab. It'll move you down to the next box. And hit the arrow again, and we wanted TDs on the Y. Okay, you should also notice it's going to save this equation in F1. That's going to be important to notice that, oh, my equation's been saved in F1 when we want to find it. You'll never fill out the rest of this stuff. It's all fine. Don't change it. We aren't getting. That's only if you had massive, like thousands of pieces of data or something that you would mess with all that. We are never going to have that much data. Dude, why didn't you say okay? Go. Okay. Okay. Once you hit okay, you get this slew of stuff on your screen now. And you can see why I wanted to be off in the blank area because it put in a lot of information. It's telling you it ran a linear regression. The equation was mx plus b. The slope is 0.0698. Notice it's, when I click on it, go back. Cancel. Go somewhere. It'll show you in yellow down here the whole number. Okay, folks, I'm not done, and you're racking it up, and you better be listening. So I got a whole another 4 minutes, and I'm going to use them. Okay, gave me y-intercept. What I'm after, though, what you really need to see is down here at R. Okay, and I have this written over here on the sideboard. R is really, 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 really important. And I'm sure this is a journal question. R is the correlation coefficient. Isn't that a lovely name? It tells you how well the line fits the data. Read it like a percentage. We got 0.87 here, so that means it's about an 87% fit. Our line, that's a good fit. Our line's about an 87% fit to the data. So R is going to give you an idea of how well it fits. Okay, basically we consider it, if it's over 75%, we consider it good. If it's between 50 and 75%, we consider it fair. If it's below 50%, we consider that that's a poor fit. You really wouldn't want to use it. We hope we get things that are over 75% most of the time. So that's an indicator for you of how good your line is going to fit. So R is going to matter. You're going to want to look at R. And I'm going to ask you on there, on this sheet, number 1 was find the equation. So on number 1, you could have copied down the equation that appeared on the scatter plot. Number 2. Number 3 says, what's the correlation coefficient? So you would write down the R number. And it says, how does it describe it? You would write it as a good fit, because 87 is a good fit. I think I did correlations to just the 2 decimals. 8.87 is fine. Yeah, and round them, it's fine. Okay, it's questions 5 and 6. I'm going to show you how to get to one. I'm not going to get to show you how to get to the other. I am going to record it though. Okay, I want to use this equation now to predict the future. So on 5, I said, use your equation of your line to predict the number of touchdowns a player who throws for 25,000 career yards. Okay, I don't want you to go get that equation and plug 25,000 in and type all those numbers in. Your calculator will do all this for you. Okay, you remember when I said it saved it in F1? Okay, you can go to your calculator and have it show you the value for any number of yardage. You can make it pop that up for you. Okay, you all need to watch this. You use this on a lot of things throughout the year. Control T pops up a table of values. Control T, T for table. Whoa. So I'm going to press Control T. First time it's going to ask you which equation do you want it to use. Never use this something dot something stuff. That's junk from the regression. F1 is where it stored it. So I'm going to choose F1. Okay, it's telling me if they threw for 1 yard, they'd have negative 26 touchdowns. Okay, our question was if they threw for 25,000 yards. Do you want to scroll clear to 25,000? Please don't. It'll burn your battery doing it. You can tell it to skip to 25,000. If you press menu, there's only 2 choices. You want to change the table, which is number 2. This is also all on the purple sheet. You want to edit the table settings, number 5. And it'll ask you, where do you want the table to start at? We want it to start at 25,000. Then I don't have to go scrolling to 25,000. The rest of it you won't have to change. So say, okay, I want that. Now here's the annoying part. It will always go one past. It makes me angry. It went to 25,001. You got to arrow up one to get to 25,000. It'll go one past every time. So 148.578 was your answer. And I didn't get you guys to change your settings. Ha! Okay, you can do this whole worksheet. You can do this worksheet, except you can't do the ones if I'm giving you y and asking you to find x. So you can't do 5 or 6 on each one. It mixes up, so I can't tell you. You'll have to read. I'll probably send out an information on that. Just leave it on my desk. Thank you. I am actually going to keep recording here and do the other part of this as well if anybody's dying to get ahead. Otherwise, we'll be playing with it at the beginning of class next time. This takes practice. Not hard, but it takes practice to learn all those button pushes. All right, the last part of this. I'm right now stuck in this table, and I need to get out of the table before I can do anything else. Once again, Control T takes you out and takes you in all the time. So if I go Control T in and out, I'm just pressing Control T. It takes me into the table. It takes me out of the table. So that's all you have to do to get in and out, Control T. Okay, the last type of question, if you read number 6 on problem 1, use the equation of your line, predict the yardage thrown of a player with 600 touchdowns. Okay, lots of people will think they can use Control T, but look at what it's giving you over here in the second column. It's giving me all these decimal numbers. Do you think I'm ever going to find exactly 600? Plus, I'd have to scroll forever. I can't say jump to a y coordinate. I can only say jump to an x coordinate. So this is not an efficient way. We do not use table in order to find the actual points. Instead, we find it off of a graph. And this is your most complicated set of steps to do. Okay, not off the scatter plot, but off a graph page. So I'm adding a page with Control Doc. One more time, that was Control Doc. I am adding a graph. Notice up here at the top it started at F2. F2 means it it goes to the first empty line, it knows F1's got an equation in it. Well, F1 is what I want to graph. So I hit up arrow and I went to F1, and there's my equation, but it's not graphing it until I press enter. And you're going, but it still didn't graph it. You have to press enter on F1, but think about it. Look at the data in this table. This table had values running in the hundreds and in the tens of thousands. This is growing from -10 to +10. So I have to go change the window settings. Zoom out will not work here. I'm going to go to menu, number 4, window, then over to number 1 at the top, window settings. And you have to use this table of values to set some common sense values. Okay, x-axis was yardage. Look at what the yardage is going. It's going from 40,000s to 70,000s. So minimum's 40. And maximum, I'm going to overshoot this quite a bit. I'm going to go 80. I always go big. Okay, y-axis, that was to 80,000. Y-axis, I'm going to do the minimums. If you look at the y-coordinates, that was the touchdowns. Touchdowns were the y-coordinates. And they're running from low 200s up over 500. So we're not going to go lower probably, but I'm going to run my numbers higher, at least to 600 here. Hey, there's the equation of my line. Now, this is a problem. Notice it's not showing me many decimal places. I want it to show me more decimal places in that equation, and this is something you'll need to do one time while you're on a graph page. You won't have to do this all the time, but you're going to go menu, and at the very bottom you'll see number 9, settings. We need to set this one time so it sticks with us. Number 9, settings, and then it says float 4. That means it's only going to show you 4 significant digits. I need it to show me as many as there are, so I want you to change it to plain float. Not float 4, but float. It will not stick until you go down and click on Make Default. So you've actually got to move downward to the Make Default. Click Make Default. It's going to ask you, are you sure you want it to stay that way? And yes, we do. Hit OK. So that it stays on 4. Now see, it's showing me lots of decimal places, not just a few. Okay, the question is though, how do I use this graph? I wanted to know when it's going to hit 600 touchdowns. What I want to do is I want to put a line across the top of, across my screen at 600, and I'm going to find where these two intersect. Okay, but I have a problem. You'll notice 600 is the very top of my screen. I'm going to put the line across there now. Anytime you want to put an equation in, you press tab. Tab brought up, I can go up and see F1 and come back down and see F2. I want to put in F2 equals 600, so it puts a line across at 600. And you'll see there's a red line at the very top edge of the screen. I want to know where the red line and the black line intersect. Can I see that? No, because I don't have my window expanded enough. So I'm going back to the window settings, menu, 4 for window, 1 for window settings. I need to make these numbers bigger. I need my x coordinates to go wider. So 80,000 wasn't enough. Let's guess 100,000 maybe. And this is just a guess. And then my y coordinates, I need them to go higher because that 600 is right at the top of the screen. That's hard to see. I'm going to put in about 800. Hit OK. Aha! Now it's better. I've adjusted it so I can clearly see the intersection. You have to be able to see the intersection to find it. Okay, finding the intersection itself is easy, and we will use this many times this year. You're going to go to Menu. We intersect to find a lot of things throughout this year. You're analyzing your graph. Most things you want to do on a graph page are under Analyze Graph, so that's going to become one of your friends. We're going to go down to number 6. And then you can find the maximum, the minimum, the intersection, the inflection. We want to find, of course, number 4, the intersection. So I'm going to go tell it to go to number 4, intersection. Okay, on this calculator, this is so much easier than it was on the old TI 83s and 84s. Notice down here in the left-hand corner, it's saying lower bound. It wants you to click a starting point. What you're going to do is you're going to highlight a gray region across where the intersection point is. I'm going to move over. I'm using my arrows to move over a little more, so I'm a little closer. Okay, I'm clicking the center mouse button to say here's a start point. Notice it now says upper bound down in the corner. Now I can scroll across. Watch what's happening as I scroll over here. I'm getting this gray region. And once I scroll across the intersection point, it says, hey dude, I'm intersected. And so now that I have the intersection located, just click again, and it's located the intersection point. Problem is, you can't see it, at least not very well. If you use your touchpad, arrow out there until you get the hand on it, which is really hard on this board. Hand is open. Control, click, grab the hand, and move it up out of the way. Now you can see your coordinate. Hit escape to get out of it. And so now I can see that 600 touchdowns would require over 89,000 yards. That would have to be a very long career, or you're going to have to have thrown a whole lot in that career, not too much of a running game, to amass that amount. So 600 touchdowns, it would be something very special if that ever occurs. But once again, you found the intersection point. So on your purple sheet, you have to ask yourself, when they ask you a question, do I know the x-coordinate or do I know the y-coordinate? If you know the x-coordinate, you go look up the y-coordinate in table. If you know the y-coordinate, you put a line across at y equals whatever number and you intersect. So two totally different methods for finding this. Good luck.